Now, we're going to do another one where the n is not on top, but rather, let's look at G. You see G there? You see G? Good. The number that we're looking for, the n we're looking for, it's actually in the general sum. Okay. So, let me just write it down. It's the sum of, what is this? It's 2x plus 3n from x equals to, what is that? 3 to 5. And what is the sum equal to? 51. You see, our n is not the upper value of summation. It's not in my general. It's like same like the other three questions I gave you where I say find d. It's exactly the same. So again, we're going to start with 3. Here with the 3. Then 4. Then 5. How many terms are there? Still thinking? 3 terms. 5 minus 3 plus what? How many terms? 3, 4, 5. 3 terms. How many terms? 3, 4, 5. 3 terms. How do you find it? 5 minus 3 plus 1. Upper minus lower plus 1. Yeah. Page 67, page 65, 64. Page 64. The story is there in the example. Are we clear? Okay. Right. So let's see. 2 times 1 plus 3 plus 2 times 2 plus 3. You have to do 3 of them, right? Plus 2 times 3.
So what are you saying?
What are you saying? Exactly. And I was talking about it. And guess what? I'm guilty of the same thing. Can I take this stuff away? Off? Because I think you must be done with that. Just remember this is not your work. Okay, so we are going to start with 3, 4, 5. So it's, be careful, it's an error that everybody can do. 6. Please don't only add 6 plus 3 and it's not 9. It's not 9 terms. 8. 10. Yes. Question. Is this going to be an AP or a GP? Yeah, it's an AP. So let us see. If we subtract 8 plus 3n minus 6. Now here you must be careful. Plus 3n. That means I'm taking term 1, term 2, term 3. You want to see if it's the same thing as 10 plus 3n minus 8 plus 3n. So the 3n's will disappear, right? Alright? So 8 minus 6 is what? 2. And this is also going to be 2. The 3n's will disappear. So therefore, we are dealing with what? Arithmetic series. What is our first term?
8.
But also related.
6 plus 3.
Okay. What is we're looking for the sum. Anyway, the way I wrote it here, I don't have to use the sum any formula. Because it's just 3 terms. It's 1, 2, 3 terms. So you can go 6 plus 8 plus 10 plus 3n plus 3n plus 3n equals to 51.
Oh, sure.
You follow what I'm saying? Oh.
No need for the comment.
Is that true? I will show you. People must stop sleeping. Alright? Let's use S of n. We know the first term. And we know the last term. Right? So, we are looking for the sum of 3 terms. Yes? So, it's a half of 3. What is the first term?
6.
What is the last term? You get it? The last term. Yes? But I would not have been doing this if the terms, that number was 40. Okay?
Yeah.
Right. This is equal to what? Happy? Okay. Inside you have got 60 plus 6a. Are you with me? Here you have 3 over 2. Now I'm going to get rid by multiplying both sides by the reciprocal of that. 17 times 2 is 34. Now for those of you who don't know how to get to 34, 3 goes in 51 17 times. Get. And 17 times 2 gives you that 34. Now take away 16. Now what is 34 minus 16? Don't worry about it. Whatever that answer is that you don't know, you divide that answer by 6. And what say you? N is what? She said N is not there. Yes, it's not there, but now it's there. We were supposed to find N. So N can be on top of the summation, the sigma notation. N can be in a general form, and then there's one last one where they make it an inequality. Look, G and H is exactly nearly the same thing. You follow what I'm saying?
Yeah.
H should not be a problem for you. Or unless you want to know. Okay, let's do it. Because we don't want to assume whether people know how to do it.
Just like this.
You say it's just like this, but you haven't done it, right? There's something there like this is a Bible study class. I'm supposed to be what? The prophet?
You're taking it in.
And you are the deacon. You're
Just
taking it in. But you're supposed to do it, and then you can take it in much easier.
It just takes something to do with it.
Come and do it on the board.
No problem.
This is what it is. Granny, don't worry, I'm going to take off this part. Look, is it not Granny? Don't bite off our. What is that guy doing? Is he stretching? Mercedes, we'll make it down now. I'll write it down for you and then you work with it. So again, find the value. Yes. Please move so people can write. It's not like let me just write it for you. Then from there you can work. Okay? Because we are writing this terrible and you forget that there are people who are writing from the book. So please. 2 raised to R minus 1. No, don't ask me. Usually what he's asking me, what can you tell me about that, sir? I think we should get Nanda live on camera, eh? Don't you think so? We should do that. Come here. Come here, man. Come here. The best substitute, Spain. Stop talking nonsense. You will help with the views. If they check it that far. Like I said, it doesn't even check these things. Huh? Do you have your phone? Did you try to talk to your father here? What is the basic reason for you not to get your phone?
The government, they are this way.
Okay, I'm not going to get involved in your stories anymore. Domestic issues. Can you tell me what in the world name is this?
3 minus 1.
And this dot is what?
I think the dot. Yeah. Because it just got to 3.
Go on, please.
Yeah. Start at 1. Yeah. 2 raised to 0.
Don't look at me, look at your friends. Okay, and then the next one becomes what? And the next one becomes?
2 raised to 2.
You guys get? This becomes square, 2 squares, 4.
4 times.
Okay. Go on. It must be be an AP.
Obviously.
So it's not the GP. Therefore,
Are you sure, sir?
because an AP you subtract, you're going to get n equals to 0. 2n minus n is going to give you 2.
2n minus n.
What is the first term?
I see.
No, don't. I'm just trying to see if you are not getting confused.
I need to
It's
divide.
probably an AP. It's probably a GP.
Let's
Test for an AP. Can I take this off?
I think it's a GP, sir.
No, don't think.
The ends will get me.
Don't think. Prove.
Let me start with G.
There you go. Start with what you think you should start with. Because when they start with AP, then GP, and I was forcing you to think in a certain order. And it's not really what I want you to do. You know you need to check for whether it's an AP, not AP, but an arithmetic series or geometric series, visible series. So you can start with any one of those. But sometimes you can see, like, wait a minute, this is AP. What is that?
2.
So that is the R. So why do you put R equals? That's like 2. Why do you put it? 2 what? Oh, okay. That's a capital letter, and we do not use capital letters here, man. Small letter.
Okay.
He's doing it on purpose, man. No?
Okay, this is our.
I will definitely have to cut that one. I should leave it. People are like, look how he's abusing the poor child. Oh, the child is going through problems in Africa. The teachers are kicking their kids. It's not easy. And then you probably have to see a therapist. Huh? Right now you're experiencing emotional distraught, trauma. The other kids are afraid to come to the board because they might get kicked.
Can I just.
Okay, so our first term is, this is an N, right, people?
But I don't need to use.
And our R is that. Okay, but let's just work from the start. Next. So, yeah, so use S of N for a GP because we are looking for that N. R is greater than, so 2 minus 1.
Just for sure.
Okay, go on. Okay. What is our first term? Okay. R, what right? R is what?
R is 2.
Okay, and our N should also be something with an N. Okay. So 2 raised to what power?
3 minus. You don't need to put brackets.
You're talking about the square bracket. Oh, okay.
31. So I just drop it. So I'll say N. This term is
Go on, please.
8 minus 1.
9.
No, 8 minus 1. What is this? 8 minus 1. 7. No, I don't.
Can you write that 7 and 9? No, it's fine. Just leave it like that. Second step. 7N. Just writing the 7N.
7 divided.
Doesn't it look better if you write 7N like that? So N equals to what?
I'm going to get 7 equals. N equals to.
Do that now. Then. Are you not supposed to like, look this one up? Do that.
I was bothered.
Good, we got that. So there are 2 left, which is inequalities. Then we are done as far as sigma notation is concerned. Can you see that? There's nothing left. I was wondering when you start with infinity now, but also because you guys look kind of tired. So let's just do those 2. I'm going to try to do it. Just finish writing down and then we finish off there. Unless we continue. What do you think? What is the time now? 1:45. Okay, let's finish. Try to take everything all at once and get a little bit confused. No? Hurry up, Mr. Bradley. So again, we should still find N. But it's just not the letter N. You see, because the N, Anna! You should take these things back, right? I'm going to use them today, tomorrow, over the weekend. I must take it.
I'll take it.
I heard you said, just take it. You had this little thing. Drink water, water helps. African water helps. African water is the best water you find out there. Man. Say water. Say water. Say it like that, water. Water. From Caribou, which is somewhere condition in Namibia. Caribou is a condition. Usakos is a situation.
Yeah.
Umaruru is a mistake. Bubbles by is an error. It's lost. Katima Mulilo is nowhere.
It's not even on the
No, it is. Well, people, these are just jokes to allow you to relax.
We are alive.
He says that every day. We're alive, we're alive. Okay. Right, so we are still supposed to find the missing value. Yes, I'm looking at my textbook. But it's just inequality now. So we have got an inequality. And I kind of like that second one because the value of A that we're looking for, well, it's the same thing through and through. Okay. So let's see. Let's start with I. So again, we've got R equals to 1, and here you have got 9R minus 14. Nothing to be afraid of there. Okay, it's a series. So we're going to have 9 times 1 minus 14 plus 9 times 2 minus 14. Please, while I do this, you can tell me exactly the 9 times 3 minus 14 plus and so on and so on. We don't know the total number of terms now. Okay, but we know that the sum is equal to that. So we don't know the last term. Okay, so this is going to give you minus what? So you are saying to me that 9
I didn't see the name.
minus 14. Is it not?
Yeah? 9 minus 14. Oh, minus 5.
Okay. Next, 18 minus 14.
4. Positive.
Next, 27 minus 14.
13.
What did you say?
13.
Is this an AP or a GP? Let's see. 4 minus negative 5 is the same as 13 minus 4. Well, this is 9, right? Because you're 80. And 13 minus 4. So we are dealing here with what?
Arithmetic series.
Arithmetic
AS.
Series.
Yeah, you know, if I use that AS, it's going to confuse you. The first term is, the common difference is 9. Okay? So, we know that the sum should be greater than 637.
We're looking for. Oh.
We're looking for what?
Ah,
N is what we are looking for.
number.
N is a number of terms which can never be a negative number. It also can't be a decimal. So if we get a decimal, because we've got an inequality, we're going to look at a number that is greater than whatever that is. Right. So which SRA formula are we using now? We're going to use this one here, 2A. Do we agree?
You don't know the last.
Because we don't know the last term. Right. So, n over 2. Then,
Well, I think I'll become quadratic.
no, sorry. It's supposed to be what?
Great whole.
Greater than?
600.
Are you together with me so far?
It's more.
Our A is nothing but minus 5. Our D is nothing but 9. Okay, go ahead and multiply the number there by 2. What is the number?
1,200.
1,217.
4.
I just want to clear the fraction.
Yeah.
Inside I have minus 19.
Yes. Plus. Yeah.
You see what I did there? You see what I did there? You remember chapter 1?
Let's bring it to it's an O equality.
So this is going to be something like this.
And
The values of x or the unknown, will it be above or below the x?
above. A is greater than
So whatever our answers will be, they will be extremes.
extremes.
Isn't that so? But we are not looking for those solutions. We are looking for one. So let's make this an equation. You follow?
Yes.
And I'm going to come back to this part. Is that fair?
Yes.
Okay. So as an equation, it becomes 9n squared minus
This is completing
19n
completing this point.
minus 1,274.
This is
Let's make it an equation for now.
completing this point. Completing this point.
You actually have a very nice calculator.
Yeah.
Yeah, so we just want
There's no time.
Set up 4 to 5.
There's no time.
What are the equation you choose?
Yeah.
Then 9 is the value of
So now it's completing this.
Then minus 19 is
There's no time.
then the question is minus 1,000.
Alright, practice.
So one answer A is 13. Press the next one.
equals to.
Yeah, just press equal to. So we get one answer is 30, or what is the other answer?
Negative 98 over 9.
Negative 98 over
Let's test.
Negative. Oh. 9.
over 9. Okay, like that. Huh?
10.8 from
You want it to minus 10 point? Or okay. So we should say minus 10.8
8,
over 9.
No, just
8, 9.
And so on and so on. Okay, now here's the thing. Because we are dealing with a quadratic inequality. Remember, the solutions of a quadratic inequality where the inequality is greater or greater than or equal to will be values above. Now, what this means is we are going to have n is greater than 13. So, or n is less than whatever that is. But this is invalid. So this one I'm rejecting. So I'm looking for a number which is greater than 13. So n is equal to 14 all day, every day. Do you see how your knowledge of quadratic inequalities comes into play here? The negative you already reject, but you can't now say because you made it an equation, therefore n is equal to 13. I made it an equation knowing that I'm dealing not with an equation originally, but I'm dealing with an inequality. So I had to sketch so that I can try to see what is my solutions going to be. So it's going to be values above the x-axis. So you need to consider 1 or 2. So obviously you're going to work with the one that is a whole number, because the number of terms should be a whole number, but it's not 13 terms per se because it's greater than, so the number greater than 13, which means n equals to 14. N being what we're looking for. Does that make sense?
The number.
Going once, going twice. So you will be able to do the last one?
Yeah.
Who wants to do it? That's the last one. I'm going to step up. This is the end of what you should know under sigma notation. Basically, it's the same stuff that we're dealing when we did all this long and hard things. Now, this is how it's going to work. Tomorrow in class, I'm starting with sum to infinity of a geometric sequence that converges upon a certain number. We're going to talk about converging and diverging series. What is the difference between that? Then we're going to look at sum to infinity. There's a new formula that you're going to do. Alright? So we're going to look at the sum to infinity, where you have a over 1 minus r. R, knowing as we know what r is the common ratio. That is why we are saying we're going to use sum to infinity of nothing but a geometric series. Because some sequences, when you write them down, they become smaller and smaller and smaller, but the sum of them gets closer and closer to a certain number. So that's what we're going to do. Then we are going to, now this means now, what we are doing with the sum to infinity, with the sigma notation, on top here of the sigma notation, you're going to see us having something like that. The infinity. So we need to down, because remember, you use, when there was a value, whatever, we use S sub n of the formulas that we know. But when we have infinity symbol here, we are going to use S sub infinity of this formula. Does that make sense? So I will also create scenarios where you will have simultaneous equation where one will be summed to infinity and the other one will be summed to maybe the sixth term or something like that. And solve them together to find an unknown. Be it A or R. Does that make sense? Going to spice it up a bit. Then we're going to work on practical situations where we take things like, just giving you one, a recurring decimal. How to use this formula to change a recurring decimal, something like 2/3, which is nothing but 0.666. So you get something like that. And we're going to use sum to infinity to write it as 2/3. But I'm not going to give you 0.666, I'm going to give you other type. But what you must realize is that this sequence forms, or this value here, forms a sequence. First term will be 0.6. Second term will be 0.06. Third term will be 0.006. So once you are adding them as you go along, those decimals, you are getting closer and closer to this number. Do you understand? So the sum to infinity of that decimal, 0.6 being the first term, 0.06, and so on. As it goes on and on and on. Smaller and smaller numbers, when you add them, what do you get to? You are getting to a number 2/3, which is that sum to infinity. This is very interesting to know that. Alright? And that should take us, once we're done with that, then I think we will do practical stuff like compound interest and some questions like that. Then we start with the binomial theorem. Now you only have a few things you need to know under that, but I'm going to try to do a whole lesson so that I can broaden your scope. So you are not just focused on what the syllabus say only, but just to have a little idea as well, how to use NCR on your calculator and choose R. Okay? Because they are giving it in the syllabus in vector form. So what I'm talking about things like that, while we are going to do that as well, the same thing. Right? I remember I did speak to you briefly about what it all means. So we're going to bring in things like factorial 5, factorial 5, which is just 5 times 4 times 4 times 3 times 1, 2 times 2 times 1, multiplying downwards. We're going to bring in formula where it's going to be quite interesting how to deal with that. Alright? So that should be towards the end of next weekend. So next week we're starting with that. Next weekend. Now next weekend is long weekend. Is it not? So we'll see. Now here's one of two things that we'll have. We'll probably do up until a certain time. But other binomial theorem things, I'm definitely going to make videos and put them out on the channel. So please, you need to be able to check, because the exam is based on chapter 1 and chapter 2. The whole of it. 75 mark paper, 2 hours. Now, the binomial theorem is not in your syllabus, the higher level syllabus. But when I do sum to infinity, it is there. So once I'm doing the sum to infinity, then obviously you cannot take. But when I'm now doing binomial theorem, because it's not in the syllabus of yours, you can now perhaps go back to visit the polynomials, the first chapter. I've lost out on a few things there. That's my time. We know the drill. Thank you. We'll see each other tomorrow in class. I'm starting officially with sum to infinity. But what I'll do in class, because I don't want to lose out, but you should also take the timetable of them, so you can know when they are coming to mathematics. And maybe you can attend also in the mornings. Oh, okay, no, that's fine. He's saying, for those of you who didn't hear, she babysit 5 babies at home. Oh, okay, you said 1. And cut the feet, please, thank you. And you are already down. What's going on? Bradley?